Before we move into building individual components, let's look at the full picture, the complete Azure ML architecture from subscription level down to individual resources. Burn this diagram into memory because it encodes the entire D1 exam domain. At the top level, your Azure subscription. Inside the subscription, a resource group. This is the logical container for all the related resources. The workspace, its supporting resources, compute, networking. Best practice for production is one resource group per AML environment. Dev, staging, prod. The workspace sits inside the resource group as the primary AML resource. Now look at the workspace level. Inside the workspace, 3 categories of objects. First, compute resources, instances for dev, clusters for training, serverless for on-demand, and AKS or Databricks for attached clusters that live outside the workspace but are accessible from it. Second, data stores, the registered connections to external storage. Third, assets, data, environments, models, and components, all versioned. Each of these asset types can optionally be promoted to a registry, which makes them available across multiple workspaces. The registry is shown in the middle of the diagram, and it deserves emphasis. A registry is not inside of workspaces, it's a peer-level resource that multiple workspaces can read from. Think of it like an NPM package registry. Teams publish assets, other teams consume them, and everyone gets the same vetted version. The exam loves questions about when to use workspace local assets versus registry assets. The answer is, use a registry when multiple teams or multiple workspaces need the same asset. At the bottom of the diagram, the security parameter, Azure Virtual Network, private endpoints that prevent traffic from traversing the public internet, and managed identities that grant the workspace access to storage, key vault, and container registry without ever using a username and password. D1, 3 covers network security in detail. For now, just recognize that the workspace operates inside a security boundary that you control, and that boundary is a first-class exam topic. The AI-300 exam includes scenario questions about workspaces design. Specifically, how to structure workspaces for a team that has multiple environments. Let's walk through the recommended pattern because getting this wrong in production is expensive. The standard approach is 1 workspace per environment. A dev workspace, a staging workspace. Each lives in its own resource group, for example, RGMLW dev-dev and RGML-prod. Why separate resource groups? Because it makes RBAC assignment clean. You can give data scientists full contributor rights in dev while locking down prod to pipeline-only automated deployments. It also makes cost attribution clear and makes it easy to tear down dev without any risk of touching prod. In dev, the workspace is typically more permissive. Shared compute instances, smaller GPU SKUs, no private networking requirements, relaxed firewall rules. Data scientists need to iterate fast, connect to notebooks easily, and run experiments without infrastructure friction. Dev is optimized for speed. Production is the opposite. Isolated workspace, dedicated compute clusters with appropriate GPU SKUs, VNet integration with private endpoints that prevent all traffic from going over the public internet, and managed identity authentication everywhere. Production is optimized for security, reliability, and auditability. The key question you'll see on the exam is, how do you move a model from dev to prod without just copying files? The answer is the registry. You register a model in dev, promote it to the organization's registry, and the prod workspace pulls that registered model from the registry. The promotion process can be gated by an approval step in your CI/CD pipeline. A human approver reviews test metrics before the model is published to the registry. Same pattern applies to environments and components. Build in dev, promote to registry, consume in prod. The registry is the bridge. Know it cold. The AI-300 includes practical scenario questions about workspace limits and quotas. The kind of thing that bites teams in production and gets escalated to the MLOps engineer. Let's cover the key quota concepts you need to know. GPU quota is the most common bottleneck in real AML deployments. GPU cores are allocated per subscription per Azure region. If your subscription has 0 A100 cores available in East US, you cannot create a compute cluster that uses A100s in that region, no matter what. You request a quota increase through the Azure portal under quotas in the subscription blade, and Microsoft reviews it. The exam knows this is a common operational problem, and will test it. There are two quota layers, and this is where teams get confused. First, the subscription level quota, the maximum GPU or CPU cores Microsoft allows for your subscription in a given region. Second, the workspace level quota, the maximum compute allocation within a specific workspace, which can be set lower than the subscription quota. If you're sharing a subscription across teams and don't want one team's training runs consuming all available GPU, you set workspace level quota limits. The exam may give you a scenario where a job fails with a quota error and ask you to identify whether it's a subscription quota or workspace quota problem. For multi-region deployments, the recommended pattern is one workspace per region. Don't try to have a single workspace span multiple Azure regions. Create a workspace in East US for your East US workloads and a workspace in West Europe for European workloads. If your EU workspace and US workspace both need the same curated environments and registered models, put those assets in a registry. The registry is region aware. It replicates assets to the regions you configure. So a workspace in West Europe pulls from a nearby registry replica instead of reaching across the Atlantic. Region selection for workspaces has three drivers: latency to your training data. A workspace in East US training on data stored in East US blob storage is faster and cheaper than a workspace in West Europe doing the same. GPU SKU availability. Not all GPU SKUs are available in all regions. And data residency compliance. GDPR and similar regulations may require that certain data never leaves a specific geography. Know all three drivers. The exam uses compliance scenarios